Now let me do this integral by two methods. They are a little long, therefore I do two videos. One video for one method, and the second method is another video. The link is below. You can go see it. Now this is the method of one. I start with letting x be sine theta. Okay, so the integral becomes from 0 to half pi now, and the log, this is sine theta, this is cosine. Dx will be cosine theta d theta over sine. It will become cotangent. So cotangent theta d theta. Very good. Then I'll let theta be half pi. Half pi. Let me change theta for half pi minus theta. Replace theta by half minus theta. So this becomes now becomes half pi to 0, and log this will be cosine. This will be sine. Cotangent. Half pi minus theta is tangent. D theta will be negative d theta. So I use this negative to switch this order. That becomes half pi log sine theta plus cosine theta times tangent theta and d theta. So this is also I. This is another. This is I. This is also I. Therefore, 2I become this one plus that one. It becomes the integral tangent plus cotangent times log sine plus cosine d theta. Very good. Then I change this one to sine, the cosine sine. So it becomes I'm not jumping. This is sine over cosine plus cosine over sine. And this one, I make it log sine theta plus cosine theta square, and not a half, they are equal. Right? So d theta. Now then, this becomes sine theta, cosine theta. This is sine square plus cosine square times half. This will be log sine square cosine square is 1 plus 2 sine cosine d theta. All right, this one equal to integral 2. This is a sine 2 theta times again. This is 1, and this is a log 1 plus sine 2 theta. Right? Yeah, very good. Then I let u be 2 theta. So this will be from 0 to pi now, and sine u, and the log 1 plus sine u, and this is half d. Yeah. Now, from here, well, I try to verify something. Okay. This, well, if you know that sine function is symmetric with respect to half pi, right? This is sine, this is half pi. So it's symmetric with respect to this. So this one is equal to 1/2 of this, right? Equal to half, and sine u log 1 sine u. This is equal to this because of symmetry. Now, if you don't like a symmetry, we can prove it. Let me try to prove this one. Okay, prove this one is equal to this. We start with this 0 to pi, and the function of sine pi. Okay, how do we prove this one? This is pi, yeah. Function sine pi, and d u, right? Yeah, this one is equal to from 0 to half pi function sine u du plus from half pi to pi function over sine u du, right? So this one is okay. Half sine u du. This one, let the u be pi minus x. So this one equal to sine u is the same as sine x. This will be negative dx, and this will be when u equal to half pi is half pi. When u equal to pi is a 0, right? So I use this negative change, this one switches the order. Therefore, this one is equal to that. So this one equal to function sine u from. So I proved this one equal to this. This is the reason this is equal to from 0 to half pi, and the sine u 1 plus sine u, and the du. Okay, because this 2 cancel with a half. See, if you know the symmetry of a sine function, then you can directly have that. See, or I just proved it. All right, so let's continue. Continue from here. So my 2i is equal to 0 to half pi sine u under log 1 plus sine u du. All right, good. Now then, from here, well, I use a Weierstrass substitution, which means that u equal to tangent half t. Right? You must be familiar with this substitution. So this one is equal to sine will become 2t 1 over t squared, and log 1 plus 2t over 1 plus t squared, and the du is equal to 2 dt over 1 plus t squared. So this one equal to, this is boundary have been changed from 0 to 1. So from 0 to 1, and this is cancelled out, 2 cancelled out, become t log, this is common denominator, and the numerator will be 1 plus t squared plus 2t, which is equal to 1 plus t squared, and dt. Very good. So my 2I is equal to, from 0 to 1, this is t. This could be written as 2 log 1 plus t for the numerator. For the denominator is minus log 1 plus t squared. Yeah, dt. Wow, it's quite long. Now then, I divide by 2, right? So I is equal to, cancel that 2, I have a 2 integral from 0 to 1, t and log 1 plus t dt. That is the first one. The second one is 1/2 integral t log 1 plus t squared. Yeah, from 0 to 1. Okay. Now then, use a well, expansion of a log function. Log 1 plus t is equal to sigma n minus 1 to n minus 1 t to the n from 1 to 0. If you don't put this negative one here, and you put a negative outside, so negative of this one, or negative 1 to the negative 1 minus 1. See, that is the same thing. All right, so this one is equal to, now the integral and the summation n equals to 1 to infinity, and n and a t negative 1 to the n minus 1 and t to the n, right? And dt. That's this one. And minus 1/2 integral Wow. This one is this sigma 1 to the infinity. This is n. This is t, right? T here. For this one, I have a negative 1 to the power n minus 1 to the t to n. Yeah. Okay. Because this is t squared. This is t to n. All right. Then this equal to, well, since t in 0, between 0 and 1, so the series convergent, so we can switch the operator, become this, right? Then and take n out, negative 1 to the n minus 1. This integral, t to the n minus 1. This is t minus n and dt, right? This is for this one. And minus the second one. No, I switch the order. Sorry. Switch the operators. And I take the n out. Negative 1 to the n minus 1. Integral. And t to the n minus 1. Very good. So this one equal to sigma n to 1 infinity. This integral is t to the n, right, over n to 1 minus 1 half sigma n. This one is equal to 2n, right, to the tn. Well, this is TDS calculations. So this one is equal to sigma n minus 1. Wow, this is n squared. And k minus half. And sigma n equal to 1 to infinity. This will be what this will be half. This is 2n squared, right? 2n squared, yeah. Minus 1, yeah. Yeah, this is a 2n, right? Sorry, this is 2n squared. 2, yeah, 2 times n squared, yeah. It's correct. Let me continue from here. All right, and this one is equal to, okay, this is I, right? We go back to I. Yeah, this is I equal to sigma n minus 1 to n minus 1 minus, this will be 4 sigma n minus 1 to the n squared. I forget this -1 to the n minus 1. Forget that one. Okay, good. Then I can combine them. Becomes 3/4 around this. And this. All right. Then what? Now, this is the first term is a 1, then a negative, right? 2 square, then plus 3 square, minus 4 square, plus 5 square, and a minus. Well, that means every even number power is a negative. So this one is equal more or less like the, well, this is all positive, right? From 1, 2, 3, 4, and it's all positive. This is Basel, and the minus twice all those even numbers, minus twice all those even numbers powered, right? Infinity. Yeah, because you take a 1 is not enough. You take a 1, then you see you need to take a 2, then you have this even powered negative. See, that means 3 minus power over 6 over 6 pi 6 pi square over 6 minus this is 4, right? 4, so half. Yeah, so that's a 12, huh? 66, 12. So 3 over 4. This is 12. Oh, 6. Yeah, that makes 16. So this is the final answer. Very good. Okay, this is a method of 1, and method of 2 will be in another video because that's quite long, and the link is below. You can go see it, the method of 2.